So now that we've walked through the inputs of a solver and the outputs that get generated by a solver, and we've explored the relationship between inputs and outputs, I'd like to spend time in this video talking about how to actually interpret those solver outputs. I see a lot of videos, whether they be in training sites or YouTube videos, of people opening up PioSolver or GTO Plus and analyzing a particular hand. And in general, the author of these videos tends to walk through a specific solver output and tries to explain to the viewer what the solver output is actually trying to say, and ultimately trying to take away some insights from that particular solve that they can use in-game execution. I tend to think that that's a poor way of using solvers, because I think that is not necessarily understanding very well what a solver output actually is. So we're going to spend some time in this video talking about what a solver output actually is, and I'll go back to that example in a minute and talk about how I think you should be looking at solvers as an alternative to many of the videos that I see on various training platforms. For this particular example, I want to go back to the example we used in the previous video. So this is the same scenario that we have, the hijacked versus big blind single raise pot, where we have a specific hijacked raise first in range, we have a specific big blind call range, and we have a scenario that we set up for a solver output essentially. And what I want to zero in on is the hijack raise first in range in a little bit more detail, and then what the hijack is actually doing within this example. So we'll start by looking at a solver output, right? So that's the point of this video, is interpreting solver outputs. How do we actually interpret a solver output? We're going to dive a lot more into the nuances of solver outputs. In module 2, we're going to explore PioSolver, where I will introduce information around the interface, and we'll actually open up PioSolver and I'll explain different portions of the interface and what they're actually trying to represent. And in module 4, we're going to talk about how do we actually interpret solver outputs at a more granular level using very detailed use cases, as well as in later modules where you'll see a lot more use cases where we will look at solver outputs and generate some insights from those outputs. But at a high level, I will walk through what this solver output is representing. This solver output, this is a screenshot from PioSolver. This is the PioSolver output from that King 9-5 rainbow board. And this is the in position player, the hijacks action after that big blind out of position player checks. So it's broken up into a few main sections here. We have some general information at the top, so information around the board. We have information about the game tree, so this shows us the node in which we are on now. This is the second decision point here. So we start at the root. The first decision point is the big blind's decision point, and after they've chosen to check already, now this is the second decision point for the hijack. And we also have some other kind of information here, which we'll get into in the upcoming videos as well too. The three main areas here that I do want to touch on within this video here is going from a macro level down to a very micro level. So starting at a macro level, this section up in this upper right portion of the slide is really focused on the overall range. So you can see here the overall range for the hijack at equilibrium bets 94.07% of the time and checks 5.93% of the time. We can also look through some of these buttons here and see overarching metrics and KPIs for that particular macro range level, at the range level. And all of this up here is looking at things of how does the overall range of the hijack raise first in range interplay against the big blind defense range. Moving over to this second bigger box here on the left-hand side, this is our 13 by 13 grid. If you're familiar with Jennifer Shahadi's awesome podcast, The Grid, you know that there are 169 unique hands in No Limit Hold'em, and a lot of times that's represented by this 13 by 13 grid. The way this grid is organized is the diagonal is made up of pocket pairs, so aces in the top left, pocket deuces in the bottom right. Anything to the upper right of this diagonal are the suited hands, so going from ace king suited all the way down to 3 deuce suited. These are all suited combinations. And then anything below the diagonal are all offsuit hands. So it mirrors the top side, but these are the offsuit combinations. So we have ace king offsuit here below the diagonal and 3 deuce offsuit below the diagonal. And within each of these particular boxes, we can see each hand has different compositions, right? So at an overarching macro level, the range bets 94.07% of the time and checks 5.93% of the time, but each individual hand might have a different breakdown or composition. So aces here appears to bet 100% of the time or close to it. Whereas hands like pocket kings or 10-9 suited or pocket eights here or 8-7 suited has some portion of that hand checking at some frequency here. Each of the individual hands are going to have some varying levels of composition, but ultimately those hands that make up the overall range are going to aggregate up to the macro level in this 94% frequency. We can even dive down one more level and go to the very, very micro level of combinations. If we zero in on pocket queens specifically, we can see that pocket queens mostly wants to bet here. There's a small sliver that's checking though. Well, when we dive into pocket queens a little bit, we can actually look at the 6 different ways in which we can make up pocket queens. Because there are 4 suits, spades, hearts, diamonds, and clubs, there are 6 different ways in which we can make up pocket queens. So some of those combinations, such as the queen of hearts, queen of diamonds, or queen of hearts, queen of clubs, appear to be betting at near 100%, if not 100% frequency, whereas other combinations like the queen of spades, queen of clubs, or queen of spades, queen of diamonds have some levels of checking within their frequencies at equilibrium. So again, we can see this is the most micro way of looking at this. Everything kind of works its way from macro down to micro and then back up. So these pocket queen combinations are going to roll up to this pocket queen box. And all of the hands in this overarching range are going to aggregate and roll up to the overarching macro level box. So there are varying levels of contexts through which we can actually look at this solver output. But that doesn't necessarily answer the question of what is a solver output. And that's really what I want to spend the next few slides in this video exploring is what does this solver output actually represent? Because if you watch those videos that I referred to at the beginning of this video, where other authors of those videos or other people who are walking through PioSolver solutions, they might lead you to believe that this is the game theory optimal way to play this situation. And what I'm suggesting is that this is just one potential way in which we could be playing this situation, but it is very likely not the game theory optimal way or equilibrium GTO way in which we can be playing this specific situation. To explore that a little bit further, I'm going to go through a little bit of an exercise with you where we, similar to the previous video, we're going to start changing individual inputs to show you visually how that might affect the overall outputs. So let's start with one input, our hijacked raise first in range. So I'd like you to visualize a spectrum here where we have an axis. On the left side of the axis is a very, very tight raised first in range. And on the right side of the axis is a very, very wide raised first in range. And our solve is going to sit somewhere in the middle of this axis here. So we have our base solution where we have this hijack raised first in range of 17.1%. Now we can picture a tighter raised first in range where Maybe instead of only opening 17.1%, we're actually only opening 10.1%. Well, it's not that hard to understand or believe that if we have a tighter raised first in range here, we're ultimately going to have a stronger range, and the output here is going to generate a more betting in this scenario here. So a larger portion of the overall range will be betting. So instead of betting 94% of the time, it might be closer to 100%. And that's actually exactly what happens, is the solver here at equilibrium will be betting closer to 100% with this tighter raised first in range. We can also imagine having a wider raised first in range. So maybe instead of having a 17% raised first in range, the solver actually has a 30% raised first in range. And conversely to the first example, by having a wider raised first in range, we've already demonstrated in the previous video that by having more quote unquote junk in our range, we're going to have to check back a lot more because our range overall is not going to be as strong. It's going to have a lot more misses in our range as compared to that tighter opening range. Now, this is somewhat of a simplified way of looking at things. Ranges are complex. It's not just the size of the range, but it's also the composition of the range that impacts the hand. If I look at this axis here, yes, like there's probably a lot of different solves here between the 17% and 30% raised first in range. There's also probably a lot of solves here between the 10% and 17% raised first in range. But there's also multiple solves that are at the same raised first in range, because there's not only one way in which we can actually make a 17% raised first in range. We can choose different hands to be the overall composition of that raised first in range. So that somewhat complicates the idea of thinking about this from a singular dimension, but I do want to stick with this example to visualize this somewhat conceptually by understanding that we have a spectrum of opening ranges, and each of those opening ranges are going to yield differing outputs, right? The output here on the right side of the screen here, so this output here with the wider opening range looks very, very different than this output here with the tighter opening range. And there's some type of spectrum here where all of these are going to generate somewhat different outputs. We can complicate things a little bit more by adding a second dimension here. So we have our hijack opening range on this x-axis. Suppose we added a y-axis where we look at the big blind defense range on this same graph. And now we have 4 different quadrants with which we can look at and analyze the various solves. We have 3 solutions here on this x-axis, but suppose maybe we add different solves where we have wider big blind defense ranges and tighter hijack opening ranges here. So we have a couple additional solves that might get added to the mix. We might add some more solves where we've explored tighter big blind defense ranges to go alongside this tighter hijack opening range. We can look at the tighter big blind defense range against wider hijack opening ranges. We can look at wider big blind defense ranges against wider hijack opening ranges, and so on and so forth. These are just a few examples, but you can visualize that there could be a lot of different dots here on this graph. And just as in the first example, there's a lot of ways to compose a big blind defense range. There's actually probably far more ways to compose a big blind defense range than there is to compose a hijack opening range. At least in a hijack opening range, it tends to be somewhat linear. You don't tend to see people folding the top end of those ranges. You just tend to see people differ in the bottom end hands in which it chooses to open in a opening range. Whereas in a big blind defense range, there's additional choices to, do we 3-bet certain hands? Do we call certain hands? Do we keep certain hands in there as traps? How wide do we call? How wide do we 3-bet, right? So there's a lot of different ways to compose a range that could be the very same percentage. So again, we can, there's just there's only a few dots on this screen, but we can actually see that there could be a vast amount of dots on this screen because there's a lot of different potential outputs that we could have for just this one particular example. But let's say I want to complicate things a little bit more. We've already seen in the previous examples that bet sizing is a component that can really change the output of a solution. So, we have our y-axis, which is the big blind defense range, and the x-axis, which is a hijack opening range. What if we had a z-axis for bet sizing options? And as we've explored already, bet sizing is just another input, and it's not as simple as a singular dimension, just as the other two inputs aren't. But it's also an additional variable that's going to affect the outputs. Now, bet sizing options can significantly impact the outcome, as we've seen. Even if the expectation values are relatively similar using different bet sizing options, it's not that uncommon to see very, very different range compositions between two solves with different sizing options. Going back to the example from the previous video, just changing a one bet size option from 33% bets to pot size bets is going to yield a very, very, very different output and a very different way in which a solver will generate a solution at equilibrium. So finding the right balance here between maintaining simplicity and modeling reality when choosing those bet sizes is going to be important. And when in doubt, I try to tend to follow this motto of simplifying practically. And what I mean by that is using less, but also trying to mimic what actually happens in gameplay versus what might be the theoretical way to actually play a certain hand, or giving a solver more options, right? So I tend to try to be much more simplified in that approach here, because I don't want to be adding a lot more variables to a solution. But you can see this can get out of control, right? So there's other inputs here, and we can add a fourth dimension or a fifth dimension, and I obviously can't visualize that on a slide, but you can somewhat conceptually visualize that in your head to ultimately say that there's a lot of different potential dimensions, and each solver output is just going to be one point. And that's really the main point I'm trying to make here, is that single solver solution that you might watch in a video or you might do yourself, that's just one snapshot in a seemingly infinite universe of potential solver outputs. And that's where I think a lot of those videos and the people who create those videos go wrong, is that they assume that this is the optimal way to play a hand. But in actuality, this is just a single point. So rather than try to learn from that single point in space, what we should be doing is we should be thinking like a scout and creating a map of what that overall universe looks like. What does that overall three-dimensional space look like, or four-dimensional space look like? And the way in which we do that is by comparing multiple points together to see how the model changes. By doing that, we can tend to create a map, and it gives us a better picture of what everything looks like and how different things fit together. Because at the end of the day, there is, and I truly do believe that there is a perfect solver solution for every single scenario. But I also believe that it is very, very, very unlikely that you or I or anyone else is going to reach that perfect solution, because it's going to require us to be so precise with our input assumptions. And we're not that accurate, and we're not going to be that precise. Understanding that is important, though. So based on varying our inputs, even slightly, we can actually sort through a significant number of outputs. And with work, we can build that into reasonable models that we can learn from. And we can develop great findings from that. We can triangulate what the actual solution probably should be by running lots of different tests, by varying different outputs, and by mapping what that universe looks like. And that, in my opinion, is going to help hone our intuition more. It's going to train us to be better poker players rather than trying to mimic an output, which, in all honesty, is probably not going to be close to what the quote-unquote optimal solution would or should look like. Within our solves, we can use various metrics within those outputs to develop a lot of interesting understanding. So we can use our equity metrics, our EQR metrics, nut combo metrics, things like that. But at the end of the day, EV is our guiding metric. It's the thing that helps us understand strategic frequencies the most. It's the thing that helps us build implementable strategies the most. There's a lot of nodes in this game tree, and through all of the different levels of context that we can look at, through all the different levels that we can study, there's far, far, far more than we can learn in a lifetime. This King 9-5 rainbow board, we could spend hours and hours and hours looking at lots of different solves. And look, that can be very, very, very valuable. But what I'm encouraging here for you is that if you're not trying to analyze a very specific scenario here, start exploring. Be a scout here and map out what this game tree looks like, because things are interesting here and we can learn a lot by changing inputs and seeing what those outputs look like and mapping out what that universe looks like, because at the end of the day, that's going to help us create better strategies. Shifting gears a little bit, I've mentioned context here, and I want to spend the last part of this video talking through those various levels of context. I introduced this a little bit in that solver output slide, but when we're looking at solver outputs, there are different levels of context that we can view that solver output through. And I'll start at the most macro level, which is the range level. The range level tends to be this high level at which we can kind of start making overarching strategy decisions. And some examples of range levels might be if we're looking at how our overall under the gun raised first in range might play against a big blind defend range, or we might look at how 3-bet ranges interact against one another. But really looking at ranges in this context, we are trying to analyze the interplay between the set of hands within our overall range, or the set of hands that we could have at any given potential situation, versus the set of hands our opponent can have at any given point in time, so our opponent's overall range. And that tends to be very useful for macro level analyses and determining overarching incentives. A good rule of thumb a lot of times when you're at the table is if you are unsure of what to do with a particular hand, fall back on your overall range's incentives, right? So you're probably not going to stray too far off the beaten path by doing so. So having a good understanding of what your overall range wants to do in a particular situation against your opponent's range is going to lead you to the correct decision in a lot of different situations at the poker table. So studying things at this macro range level is going to be a good way of looking at a lot of scenarios. Now, we didn't touch on this next level, but going a level down, we can look at things at the hand class level. Hand classes are like group of hands. They're groups of hands that might be grouped by a particular heuristic that tend to take similar actions to one another. And a lot of times that's very, very useful for connecting us to what we might be doing in game and executing different strategies. Examples of hand classes might be when we're looking at things just pre-flop groups of hands. It could be things like suited aces, right? Or suited wheel aces as a specific example. So ace 5 suited, ace 4 suited, ace 3 suited, ace 2 suited. They tend to play similarly to one another in particular ranges. Suited Broadway hands like king queen suited, king jack suited, queen jack suited, a lot of them tend to play similarly to one another. Premium pocket pairs, aces, kings, queens, tends to play similarly to one another. Middle suited connectors, 9-8 suited, 8-7 suited, 7-6 suited, they'll also play somewhat similarly to one another. We can also group hands into hand classes post-flop, right? So this example that I have here, the 9 of spades, 8 of spades, X board, hands like that are combo draws. So queen 10 of spades, queen jack of spades, jack 10 of spades are going to play similarly to one another. Gut shots might play similarly to one another. A lot of times grouping things at that class level is going to be helpful for us. Because it's inefficient for us to understand or develop strategies for every individual hand, but by rolling things up at some sort of aggregate level, in this case here at the hand class level, we can group things together and create strategies that are easier to understand, easier to learn, and easier to implement in game. Going a level down, we have the hand level. As we've mentioned, there's 169 possible hands within a grid. These hands are things like ace king suited, ace king offsuit, queen jack suited, pocket nines, etc. And a lot of times we'll look at things at the individual hand level, and it's useful for very micro level construction exercises and understanding how our hand might play against our opponent's particular range. And then finally, we can get down to the hand combination level. So, we've already covered here that there's 1,326 unique combinations versus those 169 overall hands. There are 4 ways to make a suited hand. There are 6 ways to make a pocket pair. And there are 12 ways to make an offsuit hand. So all of those different iterations, keeping those in mind, those 169 hands can be expanded out to 1,326 individual combinations. And analysis at this individual combination level, it's the most granular level at which we can do any analysis using solvers. It's useful for when we're specifically getting into information around what is the effect an individual card or suit might have within range interplay. A really good example of this, and the most common example, is when a flush is present and you have that ace of that suit in your hand. Well, with that particular combination, you're going to tend to do different things, or you have a larger set of strategic options available to you than you would if you did not have that particular card in your hand. Because with that information, you know that your opponent does not have that particular card in his or her range. It cuts out a portion of his or her range that they cannot take that specific aggressive action with, and it opens up some options for you to take some aggressive actions to combat your opponent in that situation there too. So analyzing things at the combination level can be a useful way to study using solvers as well too. And as you continue to work through solvers, there's going to be varying levels of study at all of these different levels. You're going to be studying at the range level, the class level, the hand level, the combination level. And just the amount of data that we have in solvers, it's amplified considerably by the different levels of aggregation through which that we can actually analyze information. But applying those different levels, depending on the level of analysis that we want to do within a solver, is going to be a powerful tool in your skill set as you continue to get better using these great tools. So I hope that makes sense. I hope that is a useful way for you to kind of visualize all of this. We're going to continue to dive through these concepts in much more detail, especially when we get into analyzing outputs. We're going to look at things at varying levels of context. So if you don't quite understand how this fits all together right now, trust me, as we work through the course a little bit more, some of this will make more and more sense as we start looking into specific examples. In the next video, we're going to shift gears a little bit and talk through some of the common misconceptions that people tend to have about solvers. I'll explore a few of the main misconceptions and talk about why they are sometimes misguided. So stick with me in the next video and we'll talk about that. I'll see you there.